Okay, so I mentioned before that you were going to recognize the uh, dividing rational expressions, and you can kind of see why that's the case. Whenever you divide one rational expression by another, it's exactly like when you divide fractions. You just flip the second one and then multiply across. So if you have a over b divided by c over d, that's the same thing as a over b times d over c. So beyond that, it's exactly like multiplication. So dividing is no more difficult than multiplication as long as you know what you're doing. I mean, if you go into a quiz and you don't know what dividing a rational expression means, then obviously you're going to be in serious trouble. But if you know it and you remember it, I mean, it's not hard to forget. It's not hard to remember. Excuse me. Um, then it's going to be just as easy as multiplying rational expressions. So since this is so straightforward, I'm only going to do 2 examples instead of my usual 3. So let's go ahead and jump right into these examples. So for this first example, we'll have 4x plus 5 over x plus 2 divided by 4x squared plus 13x plus 10 times x squared minus x minus 6. Okay. 4x plus 5 over x plus 2 divided by this whole thing. And let me double check this to make sure this matches what I wrote down. Yes, that is correct. Okay, so the very first thing I'm going to do before I do anything else is I'm going to flip this second fraction. Now you could, there's technically nothing wrong with factoring out before you do that, but if you do that, it might lead you to, it might tempt you into accidentally factoring something incorrectly. So that's why I like to go ahead and before I even think about what's even in the fraction, I like to go ahead and just flip the second fraction immediately. So let's go ahead and do that. I'll go ahead and rewrite this as, we'll do some copy paste action here. So and here, it may have actually been faster for me to type it out. Okay, so now all I did here was I flipped the fraction, the second fraction. Always remember that's going to be the second fraction that you flip, not the first one. And remember, you do that before you do anything else. I'm kind of afraid that I'm going to see some people do something else and then flip the fraction and then do it at a time when you're not supposed to. So now we have it in a situation where we can deal with factoring it out. So now it's just exactly like multiplying. So if we have x squared minus x plus minus 6, excuse me, that's going to be x minus 3 times x minus plus 2, excuse me. So double check that. I'm pretty sure that's right. X minus 3, x plus 2. If we have nothing to cancel, then we'll know we did something wrong, probably. Okay, now this 4x squared, okay, this is not a perfect square, so you can guess and check with that. I will immediately say that just because I made this problem, I know what's behind it. It's going to start with a 4. See, typically for something like this, I would probably start guessing with a 2x for each one, but I just happen to know that this is 4x and then an x. So then we'll have a 2 and 5. 4x squared is 4x. Sorry, 4x times x is 4x squared plus 4x times 5 is going to be 20x. So this is going to give us 22x. So this is obviously not the right one. Just for the sake of completeness, so we know which one didn't work, I'll go ahead and finish it up. Now do 4x plus 5 times x plus 2. 4x squared plus 8x plus 5x. This is it. Because 8x plus 5x is equal to 13x. And so that matches it. So this is the correct one. So I'll put a little star by it. We're about to erase it anyway, though. So on the next line, let's go ahead and write the factored form of this. So we'll have the same thing on the left, 4x plus 5. But I'm going to go ahead and combine all of these terms. So I'm going to go ahead and put this on a single fraction is what I mean. X minus 3 times x plus 2. And then on the next, in the denominator, so 4x plus 5 times x minus 3 times x plus 2. Then in the denominator, we'll have x plus 2 times 4x plus 5 times x plus 2. Okay, so we have x plus 2 times 4x plus 5 times x plus 2. Okay, now clear all that off. Now I think about what can we cancel. Well, this 4x plus 5 cancels with this 4x plus 5. This x plus 2 cancels with this x plus 2. Oh, before I even say that, think about something else. Does this x plus 2 cancel with this x plus 2? No, it does not, because they are not on opposite sides of the fraction bar. They have to be on opposite sides of the fraction bar to be able to cancel each other. But either one you want to choose, this x plus 2 cancels with this x plus 2, or this one will cancel with this. Not both, but one or the other will. So we can say that this is equal to x minus 3 over x plus 2. So this is going to be the simplified form of this long expression right here. Alright, we have one more example for this, and that is going to be a squared minus b squared over a plus b divided by a squared plus 2ab plus b squared, or a plus b. So very first thing I do before I do anything else, I flip this this fraction on the right. So a squared minus b squared on the left. The left fraction stays the same. You do not flip both. You just flip the right one. Over a plus b. So this one on the left turns out to be the same, times a plus b over a squared plus 2ab, I accidentally put q, 2ab plus b squared. Okay, so I just flipped this fraction on the right. Now let's factor out everything that we can. Okay, a squared minus b squared. This should look really familiar because this is not only a difference of two squares, it's the prime example of the difference of two squares. A squared minus b squared. That's those are the letters the variables that we use to demonstrate what difference of two squares is. So that's going to be a plus b times a minus b, and then still over a plus b. And then now I'm going to go ahead and okay, first of all, I'm going to go ahead and write this. This is going to be a plus b quantity squared. This should also look very familiar. You can check this yourself. You have this, the square root of a squared is a, the square root of b squared is b, 2 times a times b is the middle term. So we know that this is going to be a plus b quantity squared. So I'm going to go ahead and put all of this on this one fraction here. So I'm going to go ahead and put a plus b. This a plus b came from this, and on the bottom here I'm going to put a plus b times a plus b. So before we just had one a plus b, that was from this, and now we have this these two a plus b's came from this here. It's the factored form of this right here. Okay, so now let's deal with what different things can we cancel. Okay, well, we have an a plus b and an a plus b on top of each other that cancel. We have an a plus b and an a plus b on top of each other that cancel. Can we cancel these two? No, we absolutely cannot. They are fundamentally different. So that means we have a minus b over a plus b, and that is going to be our final simplified form. This will be our final answer. Okay, so just remember that what I did before at the beginning, this is the basic rule for dividing rational expressions. I thought about going into the theory of explaining why that is how you divide rational expressions, but that would take a really long time, and I don't think too many people would be interested. But remember that's very important, and remember that's exactly what you have for dividing fractions. It's not even just fractions, it's actually how you divide, if you think about it, how you divide any two numbers, even integers. Like say you divide 4 by 2. This is just a side note. This is not something I'm ever going to be required to do in an algebra class specifically. So 4 divided by 2. Well, that's the same thing. We know immediately, just because we know what 4 divided by 2 is, that's going to be 4. That's going to be 2. So that's also the same thing as 4 over 1, because a fraction, any number is the same thing as that number over 1, divided by 2 over 1, which is the same thing as, by using these fraction rules, 1 over 2. And now we have 4 over 2. Hopefully that makes sense so far. All I did was I flipped the fraction on the right, because so 2 over 1 became 1 over 2. And then we multiply across. 4 times 1 is 4. That looks more like a pitchfork than a 4. 4 times 1 is 4. 1 times 2 is 2. Now, this is the same thing as 2 times 2 over 2. And one of the 2's will cancel. We'll have just 2 left. Now, obviously, whenever you divide 4 by 2, you don't usually think of it using that thought process, but the point being that flipping and multiplying is technically what you're doing whenever you're dividing. Okay, that concludes section 7.2. I will see you in 7.3.